What does it take to actually build a full chess app in the Rust programming language? Legal moves, checkmate detection, timers, and themes. I built it all, and I'm going to show you how it works. This is a native desktop app built with eFrame and egui. Egui for the user interface, shakmaty for chess rules and legal move generation, resvg, usvg, and tiny-skia to rasterize SVG assets, and plain Rust state structs to manage selections, clocks, settings, and game history. So, I also have a list of things that we're going to talk about during this video. So first of all, building a Rust desktop chess app with egui. Alright, so before we jump into the code, I'm going to talk about how I generated the prompt for this, and then we'll go into the code right after that. So the first prompt, I basically was asking Claude Code if there's any chess image sets that I can use to make a desktop app in the Rust programming language. And so it gave me some options, and so I found, first thing I did was find the chess pieces and the board colors, or the SVGs for the board. And then it kind of gave me some tips for it. And then once I had that, I gave it a screenshot of the names for that and said use this to create the code. And so it recommended some crates I should use. And then it had the first version of the prompt. So I read through the prompt, and let's see. Then I told it it needs some comments. Read through it again, and so I went through this, a few times, back and forth. Was asking about chess engines, and then I was mentioning I was going to explain this in a YouTube video, so I wanted to add a bunch of stuff about that, and I was like, just focus on building the app, and I'll worry about the YouTube stuff. And then I separated, I was going to add a chess engine so that you can play against the computer. At the moment, it's just a local 2-player game. But you can add, I might add a chess engine. Maybe the next video that I do, I'll do a chess engine update for this Rust app. But I want to keep it fairly simple, so you can kind of see how a Rust chess app works. All right, and so as you can see, I had quite a few prompts, and then finally, I got it down to a prompt that I wanted to use. And as you can see, I like how Claude Code has this, it's got like a code editor right here. It pops open for you so you can see what it's generating for you. So this is the final prompt that I used to actually feed into Codex. And so, basically tells it use a Rust language, some chess rules, shakmaty crate. Then place all the assets in assets folder. Gave it some other rules, some simple stuff, project structure. Basic example of a cargo.toml starting point. All right. And then, so that's the prompt I finally went with. And then I jumped over to Codex and ChatGPT and actually built it out. It took a while, but got it done. And so, all right, let's check out the code. So, separating the game logic from the user interface. So the chess rules are not handwritten in the user interface. The game struct wraps shakmaty, which handles legal moves, checkmate, stalemate, castling, and promotion legality, and the other chess logic. Alright. And so the UI asks the game model questions. What piece is on this square? Whose turn is it? What legal moves start here? Is the game over? And this separation keeps the UI focused on display and input while the model owns chess correctness. Alright. And so egui redraws the whole interface every frame. Instead of creating permanent button objects, the app rebuilds the sidebar, board, and overlays each frame from the current state. And the important idea is state lives in ChessApp. And the UI is a visual result of that state. Now, when a button is clicked or a square is selected, the state changes and the next frame shows the new result. Now, the board renderer has to convert between two coordinate systems. Let's check out the board renderer. Alright. Now, so we got UI coordinates, top left origin, rows increase downward. Then we've got chess coordinates. And so we have the grid coordinates on the chessboard, which are A through H and 1 through 8. And so I could open up let's open up the chess app so we can kind of point out some of this stuff while we're looking at the code. Alright. Let's see here. And I put plenty of comments in the code. The code will be available on GitHub, so you can check it out there. And so this is also where board flipping is handled. The app converts a clicked pixel position into a square, and it converts each square back into a screen rectangle for drawing. Alright, and so as you can see here, we have some functions: show board, paint squares. Let's see. Paint last move highlight. Paint highlights. Paint pieces. Paint coordinates. Alright, here we go. So let's check out the chessboard. So as you can see on the side, we have a sidebar. And then we have some grid coordinates. If you look on the on each square here on the left side in the bottom row, you'll see A, B, C, D, and 1, 2, 3, 4, all the way up. So that allows us to basically write down what moves we made in a simple and easy to read way. So, like for example, we have 2A to, or A2 to A4. As you can see right here on the sidebar, it's going to record our move, A2 to A4, white. And if we do black, we'll have the same thing here, A7 to A5. And I also have a flipboard feature here. So it's going to repaint all of the pixels when we click this flipboard. And so that way, if you want to play on the bottom or whichever side you want your pieces to be on. And then, like I said, we got some themes also, so we could change the color of the board down here with these buttons. All right. So let's see. Okay, where was I going with this? All right, so basically the board.rs handles painting the board and changing the board, flipping the board. It's going to repaint all the pixels on the board. It's using egui for that, as you can see here in the parameters. And let's see, paint checkmate overlay. So when the game's over, it's going to show on the screen clearly who the winner is. It's going to say checkmate and the winner. Let's see. And so that's pretty much it. And this is just for a local chess game. This is not for if you want to add a chess engine in here. That would be a little bit more complicated. So right now we basically have two main crates. We're using egui and shakmaty. And let's check out the cargo.toml. And then we also have some SVG crates that we're using, and we'll get into that in a second. Let's see here. So we're on the board. Let's moving on here. So the click flow works like this. You click one of your pieces. The app stores that square as selected. The app asks game for legal moves from that square. The board draws legal destination markers. Clicking a legal destination plays the move. So that's basically saying if you click on a piece, then it's going to highlight it. It's going to show you where you can move that piece. So depending on the piece, it's going to show you different spots. And let's see here. So obviously some of these can move farther than, some of these pieces can move farther than others. Let's see here. Let's just play this real quick so I can show. Alright, getting off track here. Alright, so promotion is a special case because several legal moves can share the same start and end square. And that's when your pawn gets all the way to the other side of the board. So let's see if we can do this here. Let's let this pawn get to the other side of the board. So if your pawn gets to the opposite side of the board, you have a promotion here. So we can get a queen. Bam. And let's see. So there's another interesting detail, and that's the castling detail. And let's see if we could find that inside the code. And as you can see, we're using shakmaty, and that's bringing in a bunch of other functions that are defined in shakmaty, like the move, outcome, piece, position, rank, square, bunch of stuff, all the logic for the game. And we're basically just wrapping around that. And so we could find the castling logic. There we go. Alright, so here's our castling logic, or our, we got a few different moves we can make. And so that's where that's defined, move castle. So for castling, shakmaty stores the king's starting square here. And then it moves to... Okay, and then they've got a function for castling side. And then it's going to map it, and it's got a... what is that called? A closure right here. So that's going to take a value and just insert it into this function for us. So wherever the coordinates are at, it's going to basically insert it into a map, and it's going to take the coordinates here. It's going to figure out where it's at based on where it's at on the board, and it'll castle it for us. All right. I probably butchered that explanation, but let's move on. So the board paints in layers. Square textures, last move highlight, legal move markers, pieces, coordinate labels, checkmate overlay. The drawing order matters because later layers appear on top of earlier layers. Alright, so the pieces and board squares are SVG files embedded with include bytes. Let's check this out. Okay, so we'll jump over to our assets. And then as you can see, our assets, this is where all our pieces are at. This is what our pieces look like. They're all .svg files, scalable vector graphic. And our squares are also the same. It's basically, these are the chessboard squares. We have a dark and a light option. So depending on which option we choose, that's all that is. Now back to assets. All right. Now, the pieces in the board squares are SVG files embedded with include bytes. And I'll show you what that means right here inside the code. I could find it here. SVG bytes. Here we go. Alright, so it embeds the SVG file into the executable at compile time. That means the app does not need to find asset files at runtime. So that speeds things up when we want to load it, and when we're moving things around on the board, it doesn't have to keep loading all these assets. It already has them. They're basically in this include bytes functions, basically going to turn it into bytes. So it'll turn it into code, so the computer can just, or the compiler can just read the code and display the pieces for us. And then we're rasterizing the SVGs. We're parsing the SVG into a tree that resvg can render. So, all the heavy lifting right here is basically converting all the pixels into, rescaling it and moving it around so that it all looks nice and smooth. And we don't have to worry about any of that logic, because it's basically handled for us. Otherwise, there'd be a lot more code, and this would be a lot more complicated. But we just let rasterize SVG, let this function handle all that for us, and we just have a nice, clean, smooth-looking app. All right. So each move record stores the SAN notation, the played move, the previous position. And the previous position is important because it lets the app undo moves exactly and know which side made each move. So let's see here. Let's make a move real quick. So we'll do this one over here. Then we come down here. You'll notice on the sidebar we have an undo right here. I should probably change that to undo move. So that's going to undo the last move. And you keep clicking that, and it's going to keep undoing all the moves. So I don't know, maybe I should take that out, but for some reason, Codex decided to add an undo move in there. But I guess if you're playing with two players, maybe you don't want people to just undo their last move. But if you make a mistake and you're like, oh man, I didn't want to do that, you could just be like, alright, just undo it. Boom. Click it. Alright. Now moving on. And then the move list is displayed in the sidebar. And so that's this right here, this move list. And then you'll notice we have an export CSV, so that will export the move list into a CSV file. And then jump back over here. And as you can see, all our moves are recorded in a CSV file, so we can check that out. And it's a little weird how it did this. It's got 3 coordinates on each line. Yeah, I might have to fix that. The output looks a little off, but alright. Moving on. So that's that. So timed games are off by default. Before the first move, the user can enable timed mode and choose 1 minute, 3 minutes, 5 minutes, or a custom amount of time. And let's see if we could pull this up here. It must be in the game. Let's see, timer. Time. See if we could find the time. Let's see. I should know where this is at. Alright. Searching through app. Over here. Yep. There we go. Okay. So, show timer controls. And so, this is the timer right here. Once you make the first move, the timer, you're unable to turn the timed game on. When we start new game, we can click on timed game on. Then we have 3 presets. Or we could set a custom time right here. So if we just do time 1, and then as soon as we make our first move, it'll begin the countdown. So now black has 1 minute to move total. And then once they move, it'll start the timer for the white. And so their timer will start clicking down. Boom. And then just like that. And so that's basically I mean, it's a pretty simple version of a chess app, but I think it has all the features you need for a two-player game. Of course, naturally, you're gonna have to play it with you know, two people are gonna have to share one computer and one mouse. You have to take turns clicking on it. But as long as you have a computer and you can install or start up this Rust app, then you basically can play chess. All right. So I'm going to let the time run down so we can see what happens after that runs down. And then as you can see, we have the last move is highlighted right here. So you can see I moved from here to here. You can hide that as well. There's a little button on the side. And, oh, wait, ran out of time. Okay, so that's what happens if your timer runs out when you're playing a timed game. You lose if your timer runs out. And then you just click on new game. It'll start a fresh game. All right. Now looking at the code, which I got kind of sidetracked there. All right, so these are the timer controls. Once again, it's coming from egui, the user interface, and that's in the parameters here. As you can see, it's being mutated and mute. That means it's a mutable parameters. Let's see here. Then you can see we have another closure right here. That's going to pull from the user interface. And it's going to decide whether the time game's on or off. And see how that handles all that logic right there. Let's see. Now when the game ends by checkmate, draw, or timeout, the board can show a prominent message. The timeout overlay appears in the center of the window, and the new game button is highlighted so the next action is clear. And this is a simple but important user interface idea. After a terminal state, guide the user toward the next useful action. All right. So basically, program it starts off in main. As you can see, it's loading these modules, which are all these crates that we've created here, and then setting the size of the window, setting the title for the window, and then starting the event loop, and it's pulling some creation context from the box. Alright, the box is basically the E-frame. And so the E-frame is going to return a result, whether it's created or whether it fails. So either way, the compiler will return some kind of result for us because of this results right here. And let's see. And then it goes into the app.rs. And so this module owns the ChessApp struct, coordinates the board widget, sidebar controls, promotion flow, and recoverable user interface errors, and translates board clicks into legal chess moves using the crate game, which brings us to the next crate. As you can see, we're importing some crates from our local project right here, and some functions from those crates. So that brings us to game. And this is the chess rules wrapper and move history management. So this module wraps shakmaty chess with undo snapshots, SAN move history, promotion helpers, and draw condition tracking that extends beyond chess outcome to include threefold repetition and the 50 move rule. All right. And so we're essentially setting up the game outcome right here with an enum. Checkmate, stalemate, insufficient material. 50 move rule. And threefold repetition. So if you move the same piece 3 times in a row, then that will forfeit the game. So I guess that's a common chess rule. So if you're out of moves or you just don't want to think about it anymore, then you just move your piece a few times in the same spot and that's it. Alright. So then we have the mutable game state backing the app UI. So we have a struct for game. And then we're implementing the game struct. And so that basically creates a position, creates repetition counts, creates the history, has functions for setting where the piece is at, where it's going to move, what legal moves it has. Alright. And so this is a lot of code. This is probably the longest one right here, about 600 lines or so. Oh, 300 lines. Which one was 600? Maybe it was board. I think board has a lot of code. Oh, only 300 lines. And promotion. What is promotion? Oh, that's right. This is just for when the pawn reaches the end, it's going to promote it. So that's what this module is for. Just changing the pawn to a different piece, whichever piece you choose. It's going to pop up a button. It's going to give you some options for, other pieces that you can use besides pawn. So that's pretty simple right there. So, and then let's talk about these SVGs. So you go in here if you want to swap these out. I actually have a chess piece prompt that I use to generate some different pieces for this app. And let's see here. Let me pull these up. So basically what you're going to want to do is you're going to want to go into your pieces folder in your assets folder. And you just want to swap all these out, but you want to make sure you have the same names for your pieces. Because that's what the code, when it compiles, it's going to look for these inside the assets. Let me show you here. So as you can see, when it includes these as bytes, it's going to look for these names in the assets folder inside the pieces folder. So if you want to change these out, you either got to change all these names or just rename your SVGs to match these. And so what we have right now is this one, but I actually created some different ones for this. So let me actually pop this open real quick. Alright, so I have this copied somewhere else, so I'm just going to delete these. Should I just delete all of them? Oops. I want to delete the black ones. Alright, I only have one set. I'm going to replace one whole set real quick. Show you how easy this is. Here we go. Boom. So we do that. Delete those. Got these other ones I'm going to copy and paste. Oh, the app's actually running right now. Should have closed it before I did that, but alright, cargo run. Oh, I got to recompile this. I got to delete my cargo.lock folder or file. So that's the thing. If you ever want to, if you ever need to rebuild your cargo crate or your cargo app, you got to delete your cargo.lock file, and that will force it to recompile everything with your. And it should have these fresh. Should have the new SVGs in there. All right. This may take a second to build again, but we'll wait. Let's see what these new ones look like. Here we go. So this is what the new bishop looks like. I created these with ChatGPT using this prompt. Basically, it's a 2D vector SVG. I basically just said it should be like ornate, elegant, and highly detailed from polished marble. Refined gold trim. I'm not going to read the whole prompt, but you kind of get the idea. Oh, here we go. And here it is. Bam. Oh, that actually looks kind of cool. I like how that turned out. And so I'll include this in the GitHub as well, the extra chess pieces. But yeah, I like how that looks. Looks a little bit better than what we had before, actually. Very nice. But yep, that's how easy it is to swap your chess pieces. You can even change the color of the squares as well. Just make sure you have a dark and a light color. But it could be any color that you want. Same thing with the chess pieces. I just chose white and black because that's the standard. But you can do any two colors you want. And so yeah, that's it. Let's see. See if I could checkmate it real quick. See how fast we can do this. Let's see. I'm trying not to waste the viewer's time here. There we go. I think I've got it here. Alright. Oop. Messed that one up. Alright, here we go. I know what I'm doing now. Do you, though? Alright, let's see. Oh, it thinks he's getting a queen. Oh, no. Oh, wait. Oh, that's right. I was going for the checkmate. There we go. Okay. I remember how to play this game. Yep, it's that easy. Then as you can see, the new game button is highlighted. Ready to start a new game. I actually kind of like these chess pieces too. Turned out pretty good. Alright, so this project is a good Rust learning example because it combines real app state, a third-party rules engine, graphics assets, file export, time tracking, and immediate mode user interface. And the biggest lesson is that a clean app is built from small responsibilities. The game crate knows chess, board knows drawing and hit testing, the assets crate knows images, and the app crate connects user actions to state changes. And so that's basically a separation of concerns within your Rust app. And that separation makes the code easier to extend, debug, and explain. And so one thing I'd probably add to this is a chess engine so that you can play against a computer. And maybe I'd work on the chess pieces as well and make some custom chess pieces. And even though it's a 2D chessboard, there's still quite a bit of room for styling the chess pieces. So, but all this code will be available on GitHub. So go ahead and like and subscribe and leave a comment down below and let me know how you would customize this chessboard. All right, that's all, folks.